Okay, at noon, ship A is 150 kilometers west of ship B. Okay, ship A is sailing east and at a rate of 35 kilometers per hour. And ship B is sailing north at a rate of 25 kilometers per hour. So the distance between the ships is changing, and we want to know how fast the distance between the ships is changing at a particular time at 4 p.m. So we're given a couple of rates. 35 kilometers per hour, 25 kilometers per hour, and we want to find another rate. We want to find how fast is distance between ships changing. We ignore the 4 o'clock for right now. Okay, I've got to write these rates as derivatives. What's changing at the rate of 35 kilometers per hour? It's the position of ship A. So I need to somehow quantify the position of ship A. So A originally is right here. Maybe after a time t, ship A would be right here. Let's call the distance between those x. Then the derivative of x with respect to t is 35 kilometers per hour. Okay, B is originally here, and after a time t, let's say it's here, because it's traveling north. I didn't mean to write that. Okay. What is changing at the rate of 25 kilometers per hour? It's the position of B. So somehow I need to quantify the position of B. So I'll let the distance between B's original position and its new position be y. So the derivative of y with respect to t is 25 kilometers per hour. You could use variables a and b instead of x and y. It's just totally up to you. I used x because it's a horizontal distance. I used y because I was dealing with the vertical distance. Okay, the distance between the ships, we could use z or c. I'm going to use d. Okay? So I need to find the derivative of d with respect to t. Okay, I have my 3 rates in the problem. I've written them as the derivative, so I've completed step 1. Step 2 is to look at the independent variables in these derivatives. Look at the variables in the top. They're x, they're y, and they're d. And I need an equation that relates those 3 variables. Well, if you look at this picture, you'll see a right triangle. This side is y, this side is d. What's this side? What's the base here? Well, the whole distance originally, look back at your picture, the whole distance between A and B originally was 150. We're calling part of that x, so the rest would be 150 minus x. So now by Pythagorean theorem, 150 minus x quantity squared plus y squared is d squared. So I'm finished with step 2 of related rates problems. Step 3 says to take derivatives of both sides with respect to the independent variable time. Okay, the derivative of a sum is the sum of the derivatives. The derivative of 150 minus x quantity squared with respect to t, I need chain rule. This is the derivative of the outside. I've got to multiply by the derivative of the inside. I'll just write my roadmap and do the rest of the work in a minute. The derivative with respect to t of y squared, again I need chain rule, so I get 2y dy dt, and the same thing for derivative with respect to t of d squared. Okay, the derivative with respect to t of 150 minus x, derivative of a difference is the difference of the derivatives. Derivative of 150 is 0. Now notice I've got an equation that relates these three rates that I identified in my first step. I've got now an equation that relates those. So step 4 is to plug in specific values that I'm given in my problem and solve for derivative of d with respect to t. But notice I've got a 2 here, a 2 here, and a 2 here. So easiest thing to do is divide both sides by 2. It's not necessary, but it's easy. Easiest. Okay, so I don't know x, y, and z. If you look back at the problem, we don't know x, y, and z without doing a little work. We can figure that out in a minute. But what do we know right off the bat? dx dt is 35 kilometers per hour. dy dt is 25 kilometers per hour. And we're trying to find the derivative of d with respect to d. Now, how are we going to find x, y, and d? Look back at the problem. Did they specifically state those values? No, but is there a way we can figure them out? How long has the ship traveled? 4 hours. Ship A is going east at 35 kilometers per hour. So 35 kilometers per every hour times 4 hours equals 140 kilometers. So x is 140 kilometers. Similarly, 25 kilometers per hour times 4 hours is 100 kilometers. And I have to figure out d. But I now know after 4 hours that this is 150 minus 140. This side of the triangle is 100. And I can now figure out d by Pythagorean theorem. D squared is 100 squared plus 10 squared. So that's 10,100. And so d is the square root of 10,100. So I have 10 kilometers times negative 35 kilometers per hour plus 2,500 square kilometers per hour equals the square root of 10,100 kilometers times the derivative of d with respect to t. Okay, so please finish this, solve this equation for derivative of d with respect to t, and then we'll start back up when you have that answer.